Mathematics is not about numbers, equations and computation or algorithms. It is about understanding. Hello children, welcome to our Guru Gedara program. How are you? I think I spent your time leisurely at home. But you have to pay your attention for your studies. You have to work hard because you have to face your O-level exam on coming year. Today I am going to talk about very important lesson, that is arithmetic progression. You can easily collect 10 marks by studying this lesson well. Then I think you have ready with me by taking textbooks and writing books. Don't you have? Okay, I'll count 5 seconds. Then you can grab your books and join with me. 5, 4, 3, 2, 1. Let's start our lesson. This is arithmetic progression. By studying this lesson, you will be able to recognize arithmetic progressions and solve problems related to arithmetic progressions. To emphasize that, I have taken few number patterns. In these 3 number patterns, you should tell me, you think, what are the next 2 terms of these 3 number patterns. Let's see, 15, 17 in the last 2 terms of the first number pattern. And the second number pattern, look at that. So, what are the next 2 terms of them? 7, 4. You said it clear, easily. Then the third number pattern, let's see. What are the next 2 terms? 0.001, 0.401. So, it's continuing. So, you can say the next 2 terms of these number patterns very easily. Look at the fourth number pattern. What is the number pattern? 3 minus 12 minus 48 minus 192. So, what are the next 2 terms of them? You think it, okay? Then I will give the fifth number pattern also. That is the fractional number pattern. You can say very easily what are the next 2 terms of this number pattern. Let's see what are the next 2 terms of the fourth number pattern. Look at that, minus 768 and minus 3072. You can get them by observing the order of the number pattern. By looking at the pattern of the numbers, you could say what are the next 2 terms of the number pattern. Let's see the fifth one, how they are coming. 1 and 5/6, 2 and 1/6. So, then let's observe how they are coming. Let's see further. First number pattern, 5, 7, 9, 11, 13, 15, 17. What's the order of that? Let's see. 5 plus 2 makes 7. You can see that. 7 plus 2 makes 9. 9 plus 2 makes 11. 11 plus 2 makes 13. So, we can continue that. It's no end, but I have finished at 17. There are only several terms. So, here by adding 2 for each term, we can take the next term. Then we can consider that by taking the difference of 2 terms. By taking the difference of 2 terms. Let's see, 5 and 7. We consider 5 and 7. We can get the difference of them. 7 minus 5 makes 2, 9 minus 7 makes 2. So, I have taken 2 consecutive terms, 7, 5. They are coming too closer. So, I have subtract 5 from 7. Why? So, when we are taking the consecutive terms, when we are taking the difference of them, you should take the previous term. You should subtract the previous term from the back term. So, likewise, we can take the difference. Let's see the next number pattern, how it is coming. You have to subtract 7 from 34, then you may get 27. Then you have to subtract the 3 from 27, you may get 24. Then you have to subtract the 7 from 24, you may get 17. Like that we can see an order there, 7, 3, 7, 3 like that. So, it's happening already there. Then you can see here not only one difference. Let's see, 27 minus 34 makes minus 7. You have to subtract 27 from 24, you get minus 3. You have to subtract 24 from 17, you have minus 7. You have to subtract 17 from 14, you have minus 3. So, like that we can follow on together. Then we can see the third number pattern. third number pattern. I think you remember that 0.1, 0.01, 0.001 and it's going ahead. So, how they are coming? Let's analyze how they are coming here. 0.1, from the 0.1 you can subtract 0.09 to get 0.01. It's easy. Then let us see the third one, third term, how it is coming. So, to take the third term 0.01, we have to subtract 0.009 from 0.01. Like that it is continuing, but in the differences also you can see a pattern. Let us see, to take the fourth term, what is the fourth term? 0.001, we have to subtract. To get the 0.001, we have to subtract 0.0009 from 0.001. Then we can continue it further to take the terms. By doing the differences also, by taking the differences also, we can find that value. Then let us see the fourth number pads. Then we have to multiply minus 3. Minus 3 multiplied by 4, we get minus 4. Then minus 4 multiplied by minus 12 multiplied by 4, we get minus 48. Then we have to multiply 4, we have to multiply by minus 48 by 4, we get minus 192. Then we can continue it further. So, there is another pattern. We can say different patterns among these 5 number patterns. Then by multiplying the first term and the multiple, the 4, we get minus 12. Then we can continue it. Then we can move to the fifth number pattern. So, I have selected different number patterns to emphasize you what are the number patterns in our mathematics syllabus. We have to study them. We have already studied about the number patterns in your earlier grades. Today, I am going to emphasize what are the arithmetic progressions among those number patterns. Okay. Here, in the fractional progression and number pattern, half, 5, 6, 1 and 1, 6, 1 and half, 1 and 5, 6. So, we can find the how it is coming. So, we can get that by adding 2 6 to the first term. First term is half. You have to add 2 6 to the half, then you can get the second term. You have to add 2 6 to the 5 6, then you can get the third term. And like that we have to add 2 6 by 2 6 for each term, you can get the next term. So, you can see a pattern there. Okay. Then by taking the differences, so I have represented here, you have to subtract half from 5 6. So, that those are the first consecutive terms. So, I explain again what are the consecutive terms. Consecutive terms are the terms which are too close in number pattern. So, here I have selected 5 6 and half. So, I have subtract half from 5 6 and you should follow the rules we are applying when we are simplifying the fractions. So, you know when you are simplifying the fractions, so when you are subtracting the fractions, you should follow the fractional rules. What are those? You have to make the common denominator when you are subtracting the fractions. So, here I have followed that. I am not going to explain those things. You have learned them in your earlier grade. Do you know? Do you know to subtract them? Okay, I know you can. So, here you have to subtract 3, then here half you have to subtract from 5 6, then you get 2 6. Then when you are taking the third and fourth consecutive terms, so we can subtract 1 and 1 6, then you have to subtract 5 6 from 1 and 1 6, then you get 2 6. Same procedure you have to follow. You have to follow the fractional rules. There is a mixed number, it is okay. Then we can take the other 2 consecutive terms. So, you have to subtract 1 and 1 6. 1 and 1 6 from 1 and half. Then we have to subtract them and we get at that time also 2 6. Okay. Then we have analyzed the given number pattern. So, there are different number patterns we have done the several things to take the next 2 terms, but you didn't think about those things, you just look at the number pattern and you said the next 2 terms, but there is something hidden. Okay. So, look at the first number pattern. So, I have selected the first number pattern I gave you. So, here you check about the first 2 terms 5 and 7, I have highlighted them 5 and 7. So, then you have to subtract them. I mean, you have to take the 2 consecutive term. You have to subtract previous term from the back term. When you take the 5 and 7, what is the previous term? 5. back term is 7. Then you subtract them. Then you get the difference 2. Let's follow others. So, then you have to take 9 and 7. Let's subtract them. But you should aware when you are subtracting, always you should subtract previous term from the back term. Then you have the difference. So, here other ones also I have followed to emphasis you, then I have represent them. Look at that. So, always I got in this number pattern 2 as the difference between two consecutive terms. So, I got a constant value as the difference, a constant value as the difference. You remind that, okay. Then you remember it. Then I will take fifth number pattern. Fifth number pattern. So, I have selected first number pattern and the fifth number pattern. I will explain why I have selected those two number patterns. Okay. Here I have taken first and second term. So, I have subtracted them and I can take the difference. So, from the first term, from the second term I have subtracted first term. Then we get the difference, but you should follow the fraction rules. Okay. When you are simplifying the fraction, you are following the rules, some rules you have to follow them. Then you have to consider the other two terms. What are the other two terms? 1 and 1/6, 5/6. Then we have to subtract them. So, when we are subtracting them, we have to subtract the second term from the third term. Then you get 2/6 as the difference. And like that we can do the same thing for other terms. Look at that, 1 and half. So, from 1 and half you have to subtract 1 and 1/6, then you can get the value 2/6 as the difference. Okay. Here also you can see a common constant value in each and every term. You can see the constant value, that is 2/6. The constant value is 2/6. Okay. That is why I have selected first number pattern and the fifth number pattern. Among those number patterns only I could see a constant value as the difference when taking the two consecutive terms. Then you should remember that. So, here I am going to explain you what are the arithmetic progressions. Okay. So, arithmetic progressions are the number sequences. So, here first I have given number patterns, mean they are number sequences. Progressions mean sequences, but arithmetic progression mean they have a constant value as the difference. Difference mean when you take the two consecutive numbers, you have constant value. So, they have common difference. So, they are calling as the arithmetic progression. Okay. So, let us see the definition of the arithmetic progression. A sequence of numbers such that a constant value is obtained when any term is subtracted from the term right after that term. They are the arithmetic progressions. Okay. Then let us see further that. So, when we are doing the arithmetic progression, I explain you there is some constant value coming when you are subtracting two consecutive terms. So, always I will take that first number pattern I told you and the fifth number pattern, because they are coming only the constant value as the difference between two consecutive terms. So, then first number pattern and the fifth number pattern we got. In the first number pattern 2 as we got the constant value, in the fifth number pattern we got 2/6. Okay. When we can define what is this constant value? It is common difference. We can name it as common difference. You have to do the sums using common difference. You have to remember that. Okay. Here common difference can be defined as D. Using the letters simple D, we can represent common difference. So, let us see how it is coming. You can select any term other than the first term and you have to subtract the preceding term. So, then you can take the common difference. Okay. You have to remember that well. Okay, you have to consider the common difference when we are practicing the sums related to the arithmetic progression. That is very important thing. Other thing is we can define arithmetic progressions as if a progression has a common difference, they are the arithmetic progression. So, when somebody asks to select arithmetic progressions, so you should check only the common difference, whether it is having a common difference. Then you can say by checking that this is an arithmetic progression. Okay. Here I am doing some few examples to find the common differences of few arithmetic progressions. Okay. So, here these arithmetic progressions, by looking at this, here we know definitely these progressions are arithmetic progressions. So, let us find the common differences of them. Okay. Here first progression is minus 15, minus 12, minus 9, minus 6. So, here I am going to ask what is the common difference. Now you know how to find the common differences of them. So, how do you find the common difference of the first arithmetic progression? How do you find the common difference? So, we have to consider the any consecutive pair. Here I have selected minus 12 and minus 15. So, I have subtracted minus 15 from minus 12. So, I was aware to subtract previous term from the back term. So, I have subtracted them. You should follow the rules coming with negative signs, do not forget them. Okay. Here minus become plus, minus 12 plus 15, it is make 3. Common difference, we know the sign of common difference, that is D, D is equals 3. Okay. Then second pattern, second arithmetic progression, look at that. So, I have selected another consecutive pair. In the first arithmetic progression, I have selected the first pair, and the second pattern I have selected, second arithmetic progression I have selected second and the third consecutive pair. I have subtracted 52 from 49. So, then we get D is equals minus 3. The common difference of the second arithmetic progression is minus 3. Okay, let us do another one. What is the third example? It is a decimal arithmetic progression, that is 0.5, 1.7, 2.9, 3.1. How do you find the common difference of that? We should select a consecutive pair and we have to subtract them. We have to subtract previous term from the back term. Here I have selected last two terms, 3.1 and 2.9. So, I have subtracted 2.9 from 3.1. So, I got D is equals 1.2. You know D is the common difference. So, common difference of this progression is 1.2. Then fourth one, that is fractional arithmetic progression. You can do that. Don't worry, you can do that. Whether it is fractional one, whether it is decimal one, you should follow the same procedure. Here we have to find the common difference of that. How do you find the common difference? Let us take a consecutive pair. So, here I have selected 4 and 1/10 and 3 and 3/5. So, I have subtracted 3 and 3/5 from 4 and 1/10. So, the answer is half. We got half as the common difference of fourth arithmetic progression. Okay, now I am going to show an interesting presentation. By watching that, you can understand what are the arithmetic progressions and what are the uses of them. Okay, let us see that.
Hi Roy, how are you?
Hi Leah, I am fine. How are you?
I'm also fine, but
Why? What's up?
I'm thinking about arithmetic progressions. Our maths teacher asked to find what are the arithmetic progressions and uses of it.
Oh, that's simple, my friend. Look at that wall. Just think 750 bricks are fixed in the bottom row. And imagine row above that has 745 bricks.
Okay, I'm imagining.
Can you say the number of bricks are in 35th row?
I can write the number of bricks in the bottom row and the next row and the next as a pattern. Then I can find the 35th term.
Oops. Okay then. Can you tell me how many bricks are there in the 100th row?
Oh, it's more difficult to figure out.
Think logically. These bricks were fixed following an arithmetic progression. Why? It has a common difference which is minus 5. Number of bricks in bottom row is 750 and row above that has 745. Take the difference between those two rows. 745 minus 750 equals minus 5, and consider other two consecutive rows which containing 745 bricks and 740. The difference is 740 minus 745 equals minus 5. So this has a common difference. Therefore, then if you know the general terms of this progression, you can find any term of this progression. We can use arithmetic progressions in our day-to-day life, such as construction activities and financial activities.
Thank you very much, Roy. Now I understood what is the use of learning about the arithmetic progressions.
Bye, Leah.
Okay, children, I think you got something by watching it. So you learned that what are the arithmetic progressions and what are the uses of it, and why we should learn a general term to make the arithmetic why we should learn the general term of the arithmetic progressions. Okay, here I am going to explain why we are taking the general term of an arithmetic progression. To form the general term of an arithmetic progression, I have selected an example. So here I have selected an arithmetic progression which is 8, 11, 14, 17. Using this arithmetic progression, I am going to derive a common general term for any arithmetic progression. So by knowing the general term of an arithmetic progression, we can find any term of an arithmetic progression. Even 100th term, 200th term, any term we can find. So actually here mentioned general term mean nth term. Nth term mean any position of the number pattern. Okay, here I will show you how it is coming. Here first term is 8. So we can represent first term of any arithmetic progressions as using simple A. In this progression, first term is 8. Common difference. So common difference of this progression is D. D is 3. How did I take that? 11 minus 8, then I got 3. Let's see how we can make the general term of this arithmetic progression. First term, we can define first term as T1, how it is coming. Here 8, 8 is the first term, and we can take the second term. Second term can be represented using T2. So T2 is coming 8 plus 3. What is 3? 3 is common difference of the previous arithmetic progression. So I told you that 8, 11, and those are the first two terms of the arithmetic progression I gave you. And how do we find the third term? We can find the third term by adding two common differences for the first term. So 8 plus 3 plus 3 make 14. Okay, then we have to find another term. So 10th term, I miss other terms because it's going like a pattern. Then I got 10th term. So 10th term can be represented using T10. So T10 can be found 8 plus how many common differences should be added? So in the third term we have added 2 common differences. Third term we have added 2 common differences. The second term, to get the second term, we have added 1 common difference. So here the 10th term, there is a pattern in between the number of common differences should be added to the first term. So here 10th term means the 10th is the position. So we must add how many common differences by observing the previous term? We must add 9 common differences. Why? We should find the 10th term. According to the pattern, we could identify that. Okay, then we are going to find the general term of this arithmetic progression. So here, nth term can be found by adding how many common differences? We don't know how many common differences should be added, but we are going to find the nth term. Nth term in the general term. So we must add n minus 1 times common difference. I mean, we have to add n minus 1 common difference to the first term. Then we get the general term of this arithmetic progression. Okay, let's see it further. Here first term is 8. So, I will build up connection between the common difference and the position. Here first term is 8, second term. So, second term we can get the second terms, we have added one common difference. So, okay, 1 multiplied by 3, 3 is the common difference, 1 is the number of common differences I am going to add there, okay, to get the second term. And the third term will come, for the first term we will add 2 times of common differences. Here how it is coming. So, then we got the answer 14. And 10th term, here I have taken 10th as the example, okay. It is going order, but here I want to say how it is coming in the middle term even. So, that is I have taken 10th term. So, to take the 10th term, I should add 9 common differences to the first term. So, I put it as 3 times 9, 9 common differences. It is easy, no? Then we got 35. And the nth term, to get the nth term, we must add 3 times of n minus 1 to the first term. Then we get the general term of this progression. So, what is the general term? We can derive it here. Using the highlighted box, I represent the first term. So, I told you, using this example, I am going to build up a general term for any arithmetic progressions, and I am going to derive that. Here the first term is I have highlighted. Then I want to say you what is the common difference here. Common difference is 3 here. Using those two, I am going to make a general term. Okay. Then using that, we can find the general term of this progression. It is coming 3n plus 5, but it is unique for this progression. But we should make a common general term for each and every arithmetic progression, because we need a general term to find any term of an arithmetic progression. Then using that, we can find any term. So, here I am going to derive for common general term. Look at this here. A is the first term of the arithmetic progression. Then second term is A plus common difference multiplied by 1. So, A plus D is coming. Third term, I am going to derive a general term using common arithmetic progression. So, here first term we can represent using letter A, we can represent second term. How? For the first term we should add common difference multiplied by 1, because in the second term we should add 1 common difference. To take the third term, we have to add 2 common differences. 2 times of common difference must be added to the first term. And to take the 10th term, we should add 9 times of common difference to the first term. Then we get first term as A, second term as A plus D, third term as A plus 2D, and 10th term as A plus 9D. So, then how do we take the nth term? So, we have to simplify that, because for the first term we have to add n minus 1 times D. So, to take that we can simplify it. We got A plus n minus 1D. That is very important. That is the nth term of any arithmetic progression. To find the nth term, we can use that. Here n mean any position. So, you can find 50th term, 20th term, 10th term, any term you can find using this. What is that? A plus n minus 1D. If you know the first term, if you know the nth term, n means the position, and if you know the common difference, you can find the given term. Okay, then we have to understand what is the common arithmetic progression. Okay, we have to understand what is the common arithmetic progression. Here, before that, I want to emphasize what we have learned. So, Tn equals A plus n minus D. That is the general term. So, we can represent that one using as the nth term. So, nth term is A plus n minus 1D, and we can represent that one as a general term also. Using those 3 methods, we can represent A plus n minus 1D. You should remember this well. If you know this one well, you can apply this to the questions for the sums, then we can do the sums correctly. Okay, then you should practice what is the common arithmetic progression. So, what is the common arithmetic progression? Here you can find the common arithmetic progression. How do you find the common arithmetic progression? First term is a, second term is a plus d, third term is a plus 2d, fourth term is a plus 3d. So 10th term is a plus 9d. I am always taking 10th term. So now I am asking, what is the 20th term? It is a plus 19d. So then what will be the nth term? So a plus n minus 1d. So I have represented that clearly. By looking at this, you can understand what are the terms. So when somebody asks what is the sixth term, so you can say, just say a plus 5d. Then if somebody asks to find 100th term, then you can say it is a plus 99d. Okay. Then we can go to the sums to emphasize that. Here I will do one example. Let's find the 15th term of following arithmetic progression. So it's basically you have to understand what are the given things. Here minus 8, minus 3, 2. First we have to identify the question what they have asked to do. 15th term, 15th term. So then you understand they asked to find T15. So what do you mean here 15th? 15th is the position. Okay. Then first you write what are the given things of the question. You can top of the sum, you have, before answering you have to write the given thing. So first term we know. Then do you know the common difference? Because we have to find the 15th term. So we can find any term using the Tn equals a plus n minus 1d. Then you remember that formula. Then you should know first term and the common difference and the position to find the 15th term. Here we can find that. First we write the given things, the known thing. The first term is minus 8 and common difference. Common difference can be found minus 3 minus 8. Then we have to find the common difference using any consecutive pair, and we got 5 of this progression. So then we can find n equals 15 because we had to find the 15th term. Now let's do now. We can do that very easily. Now we know the things they have supplied to us, and we have to find what? T15. We identify that. That's the thing we have to do. By reading the sum, we should understand that. Then we can substitute the given value for the formula you learned today. What's the formula? Tn equals a plus n minus 1d. Then here we can substitute. We have to find T15 and a is minus 8, n is 15, 1 and d is 5. Then we have to simplify that. So we can simplify it by, we can first simplify the thing in the bracket. So we got 14 when subtracting 1 from 15, and we have to follow the BODMAS rule because we have to multiply first. Now. Then 14 multiplied by 5 and you have to add minus 8 to that. Then we get T15 equals 62. Very easy. Let's do another example. Let's find the first term of following arithmetic progression. Do you have a progression here? Yes, here you have common difference. Then d is equals minus 5 and T20 equals 2. Okay, let's do second example. Let's find the first term of following arithmetic progression. Common difference is equals minus 5, T20 equals 2. Here common difference is d. But you can't see a progression, but they have given what is the common difference and 20th term. So in this 20th term, there are two data. What is that? The position and the value of the 20th term. So 2 is the number which is in the 20th place of the progression. 2 is in the 20th place of the progression. So here you have to write down as the data before doing the sum. Here you have to think what is the formula we are going to apply here. Tn equals a plus n minus 1. Do you have to remember that well? Here first you write what are the data given. First we don't know the first term because they asked to find that now. Here we have to write common difference equals minus 5 and T20 equals 2 and nth place is here 20th place. Okay, 20th place you can see 2. Then you have to find first term. You should write those things first of all. Then you try to substitute these values for the formula Tn equals a plus n minus 1d. A is, we don't know the value of a, n equals 20, and for d we have to substitute minus 5. To take the answer here, we have to simplify that. But T20, we should substitute what is T20. T20 is 22, and here we have to simplify the bracket and remove the bracket by multiplying minus 5. Then we get 2 equals a minus 95. Then you know this is a simple equation. Then we have to simplify that to get the answer for a. Then we get a is equals 97. A means first term. So first term of this progression is 97. So that's the one method we have to. Then using this formula we have found the first term of this one. Let's do another example. In here we have to find the common difference. So let's find the common difference of following arithmetic progression. So first term, a meaning of a is first term. First term is equals 2 times 3/5. And 31st term, T31st means 31st term, it is 6 and 3/10. So here I have taken fractional example. So we have to find the common difference of this one. Common difference means D. Then we think, how do we do that? What are the given thing here? First term was given and T31 also given. Then we have to write them. What are the given thing? First term 2 and 3/5, and the T31 is 6 and 3/10, and n is 31. We have to find the common difference. Common difference is don't know. We have to find that. Then let's apply these values for the formula that you have learned. Tn equals a plus n minus 1d. We are going to substitute those values for the formula. Here, first I am representing, because we are going to do the sum. Before doing the sum we have to mention them. Always top of the answer we have to write them. Then we are going to substitute the values. Tn equals a plus n minus 1d. I think you remember that now. Okay, T31. We have T31 and first term is 2 and 3/5, and 31 is the position n. N is representing 31, and 31 minus 1 times d. We don't know d. D is the common difference. Then we can get. So we have to simplify these fractions. Here mixed numbers actually. Then we can simplify by converting them as the improper fractions. So we can convert them 6 and 3/10 and 2 and 3/5. We can convert as the improper fraction, and we have to solve using as the simple equation. So here I got 63 over 10 in the left side, and the right side 13 over 5 plus 30d. Then we can subject 30d by removing 13 over 5 to the left side. Then we can simplify using the fractions rule by converting the denominators as the common denominator. Then I have mentioned that. Then we can get 37 over 10 equals 30d. 37 over 10 equals 30d. Then we have to find d. Then how do we find d? We have to remove 30. Coefficient of d, 30. We have to remove that. So how do we remove 30? We can remove 30 by dividing both sides by 30. So we get then to remove that, we can take the reciprocal. So you know how to deal with the fraction when dividing and multiplying. So when we are dividing the fractions, we have to get the reciprocal of the right hand side by converting it as the multiplication. Then we got common difference is equals 37 over 300. So this is the common difference of given arithmetic progression. So you have a fractional common difference. It's okay. You may have such a common difference. Okay, then we can move to the next example. It is, let's find the number of terms of following arithmetic progression. So number of terms, you identify what are the given things. Common difference is equals 0.5 and Tn equals 27 and first term is equals 7. Then we have to find the number of terms. Then you identify what are the given things and what are the things you should find. But you should apply those things for the formula Tn equals a plus n minus 1d. Then let's substitute the values. Here, what is the first term? First term is 7. Common difference is 0.5. Tn is 27, but we don't know n. N should be found. We have to find n. So, for the formula Tn equals a plus n minus 1d, we have to substitute these values. What are the values? Common difference, Tn, first term. We have to substitute those values for the Tn equals a plus n minus 1d. Then we are going to substitute them. First term 7 and we don't know n and we know the common difference. We have to find them. Then 27 is the nth term and 7 plus 0.5 n minus 0.5. So, we can simplify it further. Then we got 7 minus 0.5. 7 minus 0.5 we got 6.5 and we can remove 6.5 from the right hand side and we get the answer 20.5. 20.5 is equal 0.5 n. Then we have to find n. To get n, we should divide both sides by 0.5. Then we get the answer n is equals 41. But you know, in here you have to practice. You have to divide the decimal numbers by the decimal numbers. So you should practice them. You know the method of dividing the decimals numbers by the decimals number. Do you know them? If you don't know, you should practice. You may learn them in grade 8. So, I think you know those things. The answer of that n equals 41. Okay, number of terms of that progression is 41. Then we can move to another example. Let's find the number of multiples of 4 in between 1 and 150. So, here some important question. So, this is statement 1. So, find the number of multiples of 4 in between 1 and 150. So, how do we do that here? First, you identify whether it is having an arithmetic progression, because we are doing the arithmetic progression. So, first we try to find what are the numbers in between 100 and 150. So, in between 1 and 150 mean you are not considering 1 and 150. The between those two numbers we have to consider the numbers. So, what are the numbers in between 1 and 150? 2, 3, 4, 5 up to the 149 we can consider. We can consider up to the 149. Then among these numbers we have to find what are the multiples of 4. What are the multiples of 4? In here I have highlighted multiples of 4. 4 is the first multiple and 8. Then it's going ahead. So, then we have to consider what is the last number of the multiples of 4 in this progression. So, when we wrote up to 2 to the 149, 149 is not a multiple of 4. But we have to consider what is the last multiple of 4, the numbers which are coming in between 1 and 150. So, it's coming 148. You have to identify that. Now, we write the multiples of 4 as the progression here in between 100 and 150. So, what are the multiples of 4? 4, 8, 12 and it's going ahead. Here I have identified first term as 4 and the last term as 148. Okay, here also to find the number of multiples of 4. Number of multiples of 4. Number of mean you have to find n. You should identify that. Number of multiples. So, in that mean you have to find n. The first term was given, that is 4, and we can find the common difference. Common difference 4. Now, you know the way of finding common difference. Then we have to subtract the first term from the back term. Then we get the common difference, that is 4 of this progression. Then we know the nth term. So, nth term we know. If we know the nth term but we don't know what is n actually, we have to find n. N means the number of term, the position. So, here we have to find that. That is the thing we have to get by reading the question. What is the question there? So we have to find n here. Then we know 3 data, then we can apply those. We can substitute those data to the formula Tn equals a plus n minus 1d. Let's substitute them for the formula Tn equals a plus n minus 1d. Look at that. First term 4, common difference 4, Tn equals 148, and the last term is 148, so that's a Tn, and we have to find the number of terms. Let's apply them. Tn equals a plus n minus 1d. So Tn is 148 and first term 4 and n we don't know, and we have to substitute 4 as the common difference. Then we can simplify that by removing the bracket. First we simplify, because here unknown term is n. Unknown term is n. Then we simplify that and we can get the answer for n. N means number of terms. Then we have to simplify. So 4 plus 4n minus 4. Then we got 148 equals 4n. Then we can divide both sides by 4 to get n. Answer is 37. So n is 37. So the number of terms, number of multiples of 4 between 1 and 150, 37. 37 multiples of 4 in between 100 and 150. In there, you remember how did we done that? Here actually, first we identify first term and the common difference and the Tn, and we should find nth term. Let's do another example. Here you can see the example. The 10th and the 12th terms of an arithmetic progression are 68 and 82. 10th and 12th term. You have to read the sum carefully and you understand what are the given things. What is the common difference of the progression? Work out the value of the first term. Okay, so what are the given things? 10th, 12th terms. So 10th term was 68. 12th term is 82. So you have to find the common difference of this progression. But we don't know first term or other things. So just only we know 10th and 12th term. Just write them. 10th term T10. T10 is the 10th term. 10th term is equal 68. T12 is 82. Then you know, according to the common arithmetic progression, you can say any term using A and D. So if you have T10, you can find that. You can write it as using A and D. What is T10? T10 is equals A plus, T10 is equals A plus 9D. Then you can write instead of T10, A plus 9D. A plus 9D is equal 68. T12, you can represent T12. T12 is A plus 11D. So in here, instead of T12, you can substitute A plus 11D equals 82. Then we can write like that. Then we can those two as the equation. So first equation and the second equation. A plus 9D is equal 68. That is the first equation. A plus 11D equals 82. That is the second equation. So here, by looking at these two equations, you may have an idea. So we have to find the first term and the common difference. We have to find the first term and the common difference. Then by solving these two, you can see these two equations as a simultaneous equation. Simultaneous equation. You know, do you know to simplify the simultaneous equations? Do you know? I think you know that. So then here unknown terms. What are the unknown terms here? Here unknown terms are A and D. So we can simplify this. We can simplify this. How do we simplify that? So look at the coefficient of the unknown term. So here see the unknown term A. A has the coefficient 1 in both equations. Then we can remove that easily by subtracting two equations each other. So, the coefficient of them is 1 and the signs of them plus. So, if you have same signs, you can subtract them. Let us subtract them. Here from the second equation, we will subtract first equation. Then we get, when you subtracting them, you should understand. You should put the bracket to represent the equation that you are going to write in second. So, here a plus 11d is the second equation and a plus 9d is the first equation. Then you have to subtract it. But you should represent that using in a bracket, because we have to deal with the signs, okay. Plus minus, it's changing now. Then here we got the common difference and we got the first term by substituting for the other equation. That is a procedure of simplifying the simultaneous equation. Now we know what is the first term and the common difference. And here we have to consider about other question. You have to write down this question in your writing book and you try to do this, because now I am going to wind up my lesson. Before that, I am going to revise what we have learned. So, you know what are the things we have learned today? We have learned what are the arithmetic progressions. So, what are the arithmetic progressions? Arithmetic progressions having a common difference. So, in a progression you can see a common difference, they are the arithmetic progression, and you practice to find the common difference. How did you find the common difference? So, when you have a progression, you have to select a consecutive pair, you have to subtract the previous term from the back term. Then you got the common difference. Okay, you practice those things and you found the general term of them. Tn equals a plus n minus 1t. We practice those things. I think you have joined with me very well and you learned something from this lesson. Then I have to do the part 2 of this lesson, that is sum of first in terms of the arithmetic progression. I will come soon to teach you that. So, we will meet soon with the part 2 of arithmetic progression. Okay.